Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about encounter frequencies in the Shipmo 3D toolset. So for this example, we're going to use the offshore supply vessel, generic offshore supply vessel, to talk about this in a little bit more detail. So what I mean by encounter frequencies is when you look at the RAD-diff application, near the top of the application in terms of resolving the radiation coefficients, there's a suggested default range and minimum and maximum and range increment. Looking at these numbers in terms of radians per second, I had a question from a user, hey, how can I get some guidance on what might be appropriate for this? So regardless of anything, in terms of the numbers, one thing to keep in mind is when you look at the resulting radiation calculations, so if you go plot RADCO, generally speaking, particularly for monohulls, you want to make sure you're capturing the peak in the added mass, wave radiation, added mass, and damping effects, which you'll see it go up and down, and you kind of want to be able to capture things as they've settled here. Now, just looking at this, you can see that maybe we've got pretty generous capture of those effects where everything's kind of converging and steady at 7 radians per second. But there's another way to think of this too. If we go back to the RAD-diff application here, the encounter frequencies are going to be the range. The reason it's called encounter frequency is when the vessel's moving at forward speed, it's going to be moving from the waves it's encountering and exciting the system. Now, this isn't the wave frequencies per se, but it's what the ship will be moving around at, which drives what the wave radiation parameters are. So the other way to think about all of this is like, how big is your ship? And realistically, do you really realistically expect it to be moving around given how large it is at these different frequency ranges? For reference, remember, if you go back to panel hull and view the output, it's going to calculate the effective displacement for your vessel. So, this is a pretty big vessel, and we're looking at 4,000 tons. That's a lot of mass, very generally. So if we go back to this and look at this at the high end of the frequency, me personally, I kind of prefer working in periods a little bit. I find that a little bit more intuitive to work with. So we just convert this to seconds. I mean, this is under a second. It's faster than a second in terms of like how fast the ship would be moving and responding in any of the degrees of freedom. Maybe that's a little bit generous in terms of higher frequency. It's never usually a bad thing to have more. It does mean that there's going to be more calculation time to have a higher number here, but maybe we might be able to get away with something like 5 radians per second if we were to redo this analysis. And certainly going back in here, generally looking at all these plots, we're getting very generous with 7 radians per second and how everything is converging here, and maybe even lower than that. On the other end of the spectrum, we have 0.1 at the low end, and what does that correspond to? I think it's going to correspond to about 60 seconds. So that's pretty long. It's good to capture those low frequency effects, but in terms of like real waves that you'll have out in the ocean, perhaps the tail end we might realistically be seeing might be closer to sort of 30 or something like that. And certainly, with the incremental jump size here, you're gonna have one data point at that, and it's gonna move away from that briefly. So, anyway, maybe thinking about these numbers in terms of seconds, and realistically, given how big the ship is, do you really expect it to be moving at those ranges? That might help give you a bit of guidance for what to set for the encounter frequencies. Just a note here on the wave frequencies. Obviously, you want to have these with a range enough that covers the expected sea state spectrum value. So these are different frequencies. These are the wave frequencies you might be simulating in ship motion later, and that affects the excitation and diffraction calculations. These encounter frequencies are going to be related to how the hull is moving around in the water with regards to the wave frequencies. So I hope that gives you a bit of insight. Thanks for watching.